Hi there, everybody. Welcome to APES Chapter 19, Lecture Part 1. This is the beginning of our fossil fuels chapter. Excuse me. Let's begin. First off, let's talk about energy sources. Commonly used energy sources are these things we call fossil fuels. So let's look at them. Coal, oil, natural gas. These are common fossil fuels. So whenever you hear the term fossil fuels, generally we're going to be speaking of these three types. We'll discuss in this lecture some non-traditional fossil fuels that are out there now. In later chapters, we will discuss other sources like nuclear energy and biomass energy and hydropower. And then we will have another chapter on solar, wind, and geothermal, all right, entitled. So all these will be discussed in the future chapters. But this chapter focuses on these three at the top, fossil fuels. And why? Because these are the ones we use a lot of, and they are non-renewable. So your central case talks about Alberta and Canada and how they have these oil sands. And you probably are not familiar with oil sands or what they are. We will figure that out during this chapter. We will discuss it. I'll tell you exactly what they are. Well, they discovered these oil sands in Alberta, Canada, and we realized that, here in the U.S., we could utilize the oil that these sands have, and we can use it here and maybe break our reliance on oil from the Middle East, for example. So what they did is they constructed a pipeline called the Keystone XL pipeline, and it came down from Alberta down to the refineries through the central part of the United States, the midwestern part of the United States. It came all the way through. Some people don't like this pipeline; they're worried about leaks. They've tried to move the pipeline over time, make it have a more direct passage to where it's going versus the way it currently travels. So there's lots of issues that lead up to. Some of them are socioeconomic. Some of them are moving into people's sacred lands and things of that nature. That's happened in the past. So this pipeline comes right down through the midwestern part of the United States, right down the middle of the United States. All right. So here it shows it to you right here. Here's the pipeline. All right. Well, they wanted to move it, and they wanted to give it a more direct route. This created problems, and to this day, it creates problems. I believe you might be aware. Recently, there's many years ago there was a bunch of protests regarding this pipeline going through Native American land, burial land, cemeteries for Native Americans, areas where they buried their people, and they were going to try to go through their land, and it created a lot of problems. Depending on who's in charge politically, Republican or Democrat, generally determines on whether this is going to be a go or a no-go. Okay. Why would they want to make this happen? Well, it creates a lot of jobs when you go construct a pipeline. Temporary jobs, but it does create jobs. Um, the negative drawbacks are all the potential issues with the environmental issues. All right. I believe the big issue they had last time was, like I said, they were trying to go through Native American land, and it was holy land, and they did not want them to do it. All right, so this chapter is about fossil fuels. And what does this mean when we say they're highly combustible? It means they burn and they have a lot of energy, a lot of fuel. They burn, okay? And because they burn so well, they can be utilized as a great energy source. There's other energy sources. Like I said, we're going to talk about them later. Geothermal, bonds in the neutrons and protons, nuclear energy, sunlight. We're going to talk about solar energy in another chapter, okay? The ocean and the tides and the movement of water can lead to energy also. All right. The big issue, though, the reason we talk about coal, oil, and natural gas, these fossil fuels, is because they're non-renewable. Okay, non-renewable energy sources. Okay. Now, we do rely on fossil fuels currently. Why do we rely on them? Fossil fuels in our country are used to create electricity mainly. Um, a lot of people have solar panels on their houses, and I do at my house, but that is not the main way we produce electricity in our country. The main way we produce electricity in our country, we burn things. We used to burn a lot of coal, and now we have found cheaper sources of natural gas recently. So, generally speaking, right now, a lot of our electricity production in the United States is coming from natural gas production. A lot of the coal we produce or we excavate in our country is going overseas into other places. We are not burning as much of it to produce electricity like we used to. Like I said, currently most plants are turning into natural gas burning plants, and that has to do with costs. things are cheaper. It's not necessarily what's better for the environment. Natural gas is a little bit cleaner. It is cleaner to burn than coal, yes, but cleaner doesn't necessarily mean we should still be burning it. It is a fossil fuel that is contributing to climate change with all the carbon dioxide that is released. So whenever you burn any of these things, a great deal of carbon dioxide is released to the air. Okay, natural gas releases less than coal, for example, so that is why we would say it's a little bit cleaner, but it is still releasing carbon dioxide. We convert them into electricity, which is something we can travel long distance. We can use it in our house. We run our appliances. So the whole goal, in essence, why we're burning so much is just to create electricity. Cars, automobiles in our country do use it, but they are shifting towards electrical cars and hybrid cars right now. But even though there's quite a few cars that run on gas, even with that shift taking place, we would still be burning something to help charge those electric cars, right? Unless we're using solar or other renewable sources. Now, energy distribution around the world. Well, look at this picture here. All right, this says energy consumption per capita. Look at the U.S. We are red. We are the most. Us, the Middle East, a few parts here in Europe, Northern Europe over here, you're talking a lot of energy consumption per capita. Developed nations, developed countries like us, we consume the most fossil fuels. Okay, we just generally do that. What do developing nations generally use most of their stuff, or excuse me, their fossil fuels for? They use them for transportation, industry, other uses. All right, in the U.S., all right, look at this. Natural gas supplies 82% of the total energy demand, and that is because, well, not just natural gas, all these fossil fuels do 80% of our total energy demand. That number's slowly going down, I would say, with more solar coming into play, but depends on who's in charge of our government, whether it's a Republican or Democrat, on whether the push goes away or towards fossil fuels. All right. Now, net energy. Well, to extract energy or harvest energy, it requires machines, it requires energy input. So in order to, extract, for example, oil from the ground, machines are set up, roads are built, facilities are created. There's a lot of energy invested in that procedure. So they generally look at what's called the net energy. So how much energy do you net? All right. A plus net is a good thing. A negative net means you're losing. All right. So here's the equation. Energy you get, or the energy return. So for example, you pulled some oil out of the ground and that oil has an energy value, minus how much energy you put into extracting it. All right. And the whole goal is to get a large net energy. The larger net energy means you're taking out more than you're investing. Okay. So it's a calculation on whether it's worth even extracting the energy. All right. There's more to it. This is the big one. This is called the energy return on the investment. So this is kind of like what I use in class. I use an example of, think of college as a return on your investment. You're going to put money into your college education. How much money are you going to earn after your college education? So the whole goal is to not pay a crazy amount for your education if you're going to be in a low-paying job afterwards. All right. So the way you look at it is energy return on investment. It's a fraction. Energy returned. All right. So how much you get out of something over how much you invest in it. The whole goal is to have a large number like 24. 24 means 24 over 1, okay? And the value would be 24 divided by 1 would give you 24. That means you get 20, for every 1 that you invest, you get 24 times the energy, all right? What's happened over time? Well, over time, things have declined. Oil and natural gas in the U.S. have declined from a 24 energy return on investment in the 50s to about 11 is what they're getting now, because it's harder to get to the deposits. The oil, the coal, the natural gas are farther down. They're deeper. We've extracted a lot of the easier to get deposits. So now we have to go so far down or deeper in the way we drill. The equipment has gotten better. There's more investments going on in that equipment and how you utilize it. So because it's harder to get to it, we're investing more in it basically. So our energy return on investment is decreasing. If you get a value below 1, that's bad. That means you're investing more than you're getting a return. You're losing money, basically. So this is the way they look at whether an energy source is worth extracting or not. We have found a great deal of oil deposits in the United States and in Canada in the form of oil sands and oil shale. All right, here in the U.S. and here in Canada, and actually not here and in Canada. So those deposits for many years, we never extracted them because the energy return on the investment was so low compared to what the Saudis were producing oil for, or the Venezuelans were producing, or the Russians, or the Canadians. So if the value is too low, then you wouldn't extract it, basically. Now, fossil fuels. How do they form? This picture tells us how they form. Okay, let me move me a little bit here and show you how they form. So you start out, all right. Now they're showing you this is one that's sort of happening on land and making its way into a swamp. This is one happening in the ocean or a shallow sea, for example. So you're starting out with different starting material. The reason they're called fossil fuels is they start out with material that came from a living organism. Now, when we say fossil fuel, no, it wasn't probably a dinosaur. It was probably plant material or phytoplankton or different types of zooplankton in the oceans or in the seas, for example. So what happens originally? And let's do the ones here. Plant material, okay? Woody terrestrial plant material. It falls into a swamp or a body of water nearby. Why is it important to fall into a swamp? Well, because in order for this to take place, it needs what's called an anaerobic environment. So the next step is anaerobic environment. So at the bottom of a body of water, you're going to have an anaerobic or an environment lacking oxygen. So these things fall into these trees, this woody material falls into a swamp, then it gets buried. It's at the bottom of a swamp where it's an anaerobic environment, and then it gets broken down by anaerobic decomposers. All right, not aerobic decomposers, anaerobic decomposers. So an environment that lacks oxygen has to be anaerobic, or you will not get fossil fuels. So this anaerobic environment eventually leads to this material called kerogen. All right, so kerogen forms. What is kerogen? It is like a precursor, an organic molecule precursor that can eventually become the different kinds of fossil fuels that are out there. In order for this to happen, in order to get to a fossil fuel, heat and pressure deep underground. So what happens here, something falls in the swamp, it gets to the bottom, it gets buried over time. It's an anaerobic environment. These anaerobic microbes start to break it down a little bit, and it starts getting compressed and buried and compressed. Heat and pressure deep underground. Now, for a while, they turn that kerogen into, in this case, if you started with woody plant material, you'll end up with coal, for example, a layer of coal, which was originally plant material that ended up on the bottom there. Now, if it happens in the ocean with phyto or zooplankton, they sink to the sea floor, they get buried, anaerobic decomposition takes place. Also anaerobic, like I said earlier, and it's not full decomposition; it's partially decomposed because if it's organic, if it was aerobic, it would be fully decomposed and become part of nutrient cycles. But because it's anaerobic, it doesn't get fully decomposed, so there's a lot of carbon matter and other matter in there. Heat and pressure, and that kerogen in that case can turn into crude oil or natural gas pockets. Okay, so depending on what the starting material is, kind of depends. Well, that determines what you end up with. All right. Some things get frozen along the way. They don't get all the way to fossil fuels, and we're finding those types of precursors on our planet. All right. So what is kerogen? It's the organic matter that gets turned into the fossil fuel depending on what it started with. Coal, well, we just spoke briefly about coal. Coal began as woody organic matter, like a tree trunk, for example, and it got compressed, and it got very compressed, and it became a dense, solid carbon structure, a rock structure. So it's more compressed than oil, of course, and gas, because those are a liquid and those are a gas. What is peat? Well, peat, if you look at this, there's different type. Coal is called lignite, subbituminous, bituminous, and anthracite. Anthracite is the most compressed type of coal here. So anthracite is very compressed. It has the most energy because it's the most compact or dense. And then there's bituminous, subbituminous, and lignite. Lignite is the least compressed coal. Peat is it's plant material, organic woody material. It hasn't quite been compressed enough to become coal. So it starts as peat, plant material, starts to be partially decomposed underground, and then it gets compressed and compressed and compressed and compressed. So anthracite, they use it, I believe, in jewelry, is the most compressed, would contain the most energy of these different types of coal. right? So peat is what it began as, and it ends up as anthracite. How do they extract coal from the ground? And we'll talk about this later. They strip mine or they use subsurface mining. Strip mining is when you cut layers of terrain. You just literally cut layers of ground off and you just keep cutting down. Sometimes they call it mountaintop removal. That's an extreme case of strip mining. And subsurface mining is where you drill tunnels and you tunnel around. That's subsurface mining. Most people, when they think of mining, they're thinking of subsurface mining, tunnels and shafts and elevators, and where you have these people going down below the ground in these different tunnels. All right. What happens though when you're extracting all this coal? Well, destruction of habitat, deforestation, erosion, groundwater contamination, chemical pollution, soil and freshwater sources are polluted, dust in the air pollution. It's pretty bad for the planet to be mining, basically. All right, so that will conclude our lecture part 1.